Guys, welcome back to the Off-Grid Garage here in, well, it is the late night show. Man, we haven't had a late night show for a long time. Pitch black, 0 amps outside. Yeah, and we are still waiting for the tropical cyclone Alfred to make landfall. It was supposed to be this night, but now they have postponed it until next night. It is still hanging around a little bit east of Brisbane. But in the last 12 hours, it hasn't moved much, so nobody knows exactly what's going on. It is very unpredictable if we get wind, storm and rain, or if nothing happens at all. If it goes back towards the Pacific Ocean, nobody knows. But in today's video, we want to have a look at the brand new Muller Energy. The brand new Muller Energy, which is a modified JBD BMS. And this is probably a BMS where many people have waited for. And actually, we have asked for specifically this BMS. A few months ago, we had already a look. And back then, this was a video about exactly this BMS here. Look at this massive BMS here from Muller Energy. They still have got this misspelling in their name. I don't know why. And this was a 4S 250 amp BMS. Look at these massive copper bus bars. Insane, right? Unfortunately, it also came with all this cable mess here. Yeah, all this spaghetti stuff needed to be connected to this BMS. So this is actually a standard JBD BMS, which is slightly modified, because the special feature this one has is it can actually drive an active balancer. Yeah, we all know these Heltec capacitive balancers. We have used them many times here on the channel. They are great. They are working very well and balance your battery in no time. The only problem with these ones is they are running 24/7, which is not good. So they're actually doing the opposite. They are unbalance your battery. Yeah, we've done the testing here on the channel as well. So hence our friends from Muller Energy in Sydney had the idea to combine the JBD BMS with an active balancer together and turn on this active balancer exactly at the same time when the internal passive balancer is turning on. So you can basically control this active balancer through the normal JBD or Overkill app. And whatever balance start voltage you set in the app, it turns on the internal passive balancer as well as the external 5 amp active balancer as well. Same time, same app, same setting. And because Muller Energy is specialized in RV, camping, mainly 12-volt battery projects, this device from JBD came as a 4S BMS. And back then, many of you have asked Muller Energy, how can we get this BMS here as an 8S for 24 volt or even as a 16S for 48 volt batteries? And it was never clear if such a project would actually go ahead and Muller and JBD would be able to develop and design such a BMS for 8S and 16S configuration, because clearly Muller was specialized in the market for 12 volt batteries only. Well, and guess what? Muller and JBD have worked together for the last 2 years and have developed this amazing, it is actually a 320 amp BMS, but they have downgraded it to 250 amp just for pure safety reasons, so it doesn't heat up as much. But this is a true 250 amp BMS 6222S smart BMS for lithium iron phosphate batteries. And yes, it is made from JBD, the JBD. JBD is back. It is not this new energy stuff. And they also managed to declutter and reorganize all the cabling from the BMS to the display to the balancer to the battery. Look how clean this cabling looks. There's no spaghetti anymore. And this BMS is now able to drive an active balancer 8S or 16S. And here we have one of the Heltec 12S to 16S active balancers. And Muller Energy is also working very closely with Heltec in China to modify the standard version of the active balancer and make it work together with the JBD BMS from Muller. And here at the front we can see these 2 additional connectors. Yeah, we know about these ones. This is where the JST connectors plug in and connect the battery to the balancer. But these ones here we have never seen before. And if you pay close attention, there's also a twin pole connector here on the left hand side, which is soldered to the run pins of this PCB. If you have a look at the normal capacitive active balancer, we all know the run contacts are usually soldered together. But here in this special version, we have replaced this with a double pole connector. We've got the Bluetooth port here on the left-hand side. We've got the temperature sensors on this side, the discharge switch, which is another specialty of this BMS here. We've got an RS485. This is either to connect to external systems, which can then read the internal information of the BMS and battery data. Obviously, we've got the massive copper B negative and C negative again here. And down here, we've got the usual balance cable connectors from BC0 to BC22. And we also have a special connector down here, which connects the BMS with the active balancer through a double core wire. As in the previous 4S version of this BMS here, the backside is a massive aluminium heatsink. This is really not a lightweight BMS. And here in between you can also see the massive copper bus bar running across the whole BMS, connect the battery negative to all the MOSFETs, and here on the other side the same big massive copper bus bar connecting your charger and your load. And it is super easy to connect this BMS to all this cabling and also the active balancer. So the BMS and the balancer connect with these two cables. Then we've got this 2-pin wire, and this is how the BMS actually activates the balancer. Before that we had both contacts soldered together, so the active balancer was running all the time, and this is the function which is now managed by the BMS. It basically closes only these two contacts and turns on your active balancer. BMS also comes with two long temperature sensors, another 2-pole connector with open ends. This connects to the discharge switch port. And then we've got another 2-pin connector here. Yes, I know, it's getting boring, right? And this is our RS485 communication. It goes into this round port, and the counterpart is actually this 4-meter long cable, which on the other side only connects the RS485 display. So you can see where they're coming from, yeah? RVs, boats, camping, 4-wheel drives. We've got the battery and the BMS somewhere in the back, and have this one here connected with a 4-meter long cable somewhere where you can actually monitor and manage your BMS with this display. And the last but certainly not the least, because this is one of the most important features of this BMS, the Bluetooth module. And basically this is all the cabling you have to do. Look how clean this is now. That is freaking amazing. What? What are you asking? The battery, how the battery connects? Well, this is what these two cables are for. We know these cables already from these active balancers. As always, you've got two different sizes of cables. Wider part goes in here, the smaller part goes in here. And the other side is already pre-made with M6 ring lugs, ready to connect to your battery cells. So the BMS basically connects through these cables to the active balancer, and the active balancer connects through these thicker cables to the battery. Then you've got your Bluetooth communication, temperature sensors, discharge switch over here, and of course the display. Wait, they sent me actually another box. Just give me a second here. Because they realized these cables are actually not long enough to connect a 16S battery, they sent me actually these ones. These are the upgraded ones, which they are now using for this BMS. Zollstock. These are actually 1 meter long. So you will actually get these much longer cables instead of these very short ones. Look at this. This is like 400 mil or so. Yeah, and these ones are nice and long. Look at this. Perfect. I'm all the way over here and still got the cables in my hand. That's how long they are. So I've now connected the Muller Energy JBD BMS to our test battery here. I guess you want to see how this BMS works, right? And not just me talking about the length of the cable. So let's connect it. We've got the main negative of the battery connected to the BMS negative, and we also need to connect the display to negative and positive of the battery. That's what these two cables are for. All right, then let's have a look at the display, turn it on. Oh, it is just... Ah, here it comes, here it comes. 0% recharge battery, no current, 52.3 volts, 26.8 degrees Celsius, 0 hours, 0 minutes, time to empty. Page 1. Page 2, touch display. We can toggle the discharge and charge MOSFETs in the BMS. That is a very nice feature, right? Got 0 ampere hours, max temperature, min temperature, BMS set. What does that mean? Is that the cycles? No, 0 cycles here. I don't know what BMS set is. Leave your comments down below. Page 3 gives us all the 16 cell voltages. Highest in green, lowest in blue. And you can toggle through all these 3 screens with this button here as well. So at the moment the active balancer is connected to the BMS and also the battery, and it is not running. Even though if you look very closely you can see the light, the LED, the running light is a tiny bit on. See that? This very faded orange glow. This is the run LED. We will see this once we test the balancer here. The BMS is already off, but this LED light takes actually quite a while to turn off, so it gets darker and darker over time. I think it is still being powered from juice coming from all these capacitors here. So, and let's have a very quick look at the specifications of this BMS here, the JBD SP22S0001, whatever it's called then afterwards. It is actually not super exciting what's in here. This is all Chinese stuff. Here are some core specifications: 6 to 22S, 2.2 to 3.75 volts, 100 to 250 amps, depending on the version you choose. Consumption smaller than 20 milliamps and internal resistance smaller than 10 milliohms. Operation temperature is -30 to 75 degrees Celsius. Dimensions, not so interesting for us. Okay, here are some main parameters. These are just the parameters you can set. Balance parameters: 3.45 minimum, 3.5 typical, and 3.55 maximum. We can actually set this one here to 3.2 volts, so I'm not sure if these are recommended settings, but this is the lithium iron phosphate version here we have. This actually makes sense what they are saying here. 15 millivolt delta you can set. This is again something you can adjust in the app, and the balance current is from 73 milliamps all the way up to 113 milliamps. And here static equalization means passive balancing via resistor. And here are parameter settings with a PC software I don't have. And then there are descriptions in here how over voltage protection and recovery is working, and the same for current and temperatures and all this kind of stuff. So as you can see, these parameters are very basic here. It's a very basic BMS actually. The only really exciting part is the possibility to drive an external active balancer. The capacity calculation is described in here as well. I don't think the actual state of charge calculation is very accurate in this BMS here, because it has a threshold, from what I can see, of 0.9 amps. So any current under 0.9 will result in the BMS to show 0 amps. So it doesn't register smaller currents at all. And I mean, the JK BMS has 0.3 amps, Pace, Seplos, and the Tangaluma BMS I have here, they are all somewhere in between. While, for example, the Victron Smart Shunt can go all the way down to 0.1 amp of measuring sensitivity. And I think this is part of it, why it is so accurate in comparison to all the BMSs we have tested so far. Okay, yeah, there's nothing in here anymore. You can connect different options here: Bluetooth module, RS485 interface board, and also a UART communication box for your computer. But the problem is you can connect only one of all these devices at a time to this BMS. So we have the display connected, and there's no other way now to connect any further communication or even talk to an inverter or something. Alright, so let's start the Overkill Solar BMS, which should be able to connect to this BMS. It's JBD compatible. Yep, and here we can see it already. The second one is the SP04S06T. You can read it yourself. It's a 250 amp BMS. The blue light turns on here on the Bluetooth module, and no wonder it shows us the exact same data as we have seen here on the display already. We've got the charge and discharge toggle switch here as well. And if we go into the display and have a look on page 2, and here on the display, if I toggle discharge, we can see it toggles here on the app as well, and the same for charge. Look at this, beautiful. And the same here in the app. If I turn on discharge again, takes a moment, and then it turns on discharge here on the display as well. Same for charge. Yeah, they are in sync. Very nice. Now it shows 21% state of charge. Let's see if this one, yeah, it shows the same. All 3 temperature sensors, 2 external ones on the BMS and 1 internal. That's temperature number 2, temperature number 3. So number 1 is the internal one. 16 cells. Manufacturer is the JBD. And this is the device name SP22S004. Manufacturer date, battery cycles, barcode. So settings, it reads all the information from the BMS now via Bluetooth. We've got the cell number here, 16. We've got the total capacity here. So this obviously needs to go down to 5,000. And we can cycle this capacity 5,000. And whenever you change something in the Overkill app, it actually blinks up here and says, do you want to send these information back to the BMS? You click on BMS write, and it pushes all these changed parameters back to the BMS. Yeah, and then we have a whole bunch of voltages we can set here. Cell full voltage at 3.55 and cell minimum voltage at 2.8. And I think these are the 2 parameters which are actually determined when the BMS resets to 100%. And also these voltages here for each 10% of capacity. We can set individual voltages for that. It is not really useful for lithium iron phosphate because of the very shallow charge and discharge curve. But if you have lithium ion or LTO batteries, you can certainly set these voltages to match your percentage. So the BMS has actually a very good understanding what state of charge you are on. And down here we've got the balancer configuration, start voltage at 3.45. Nice to see. Delta to balance 15 millivolt. The balancer is also turned on, but not active, of course. And balance only when charging is turned off by default. Very, very nice to see. Never turn on charge balancer. It's disgusting. The software switch circuit enable is turned off. This is basically to enable the function what we see here on the BMS for the discharge switch. Okay, let me show you how this works. Okay, if we turn on this function and we go back into home, we will see the discharge MOSFET is actually turned off now, right? And if I take these 2 cables here of the discharge switch, the bare ends basically, and hold them together, make good contact, we can see the MOSFET, the discharge MOSFET in the BMS turns actually back on. If I disconnect the cables, the discharge MOSFET disconnect. Yeah, connect them again, turns them back on. And this switch here in settings enables actually this function here. If you don't want this, just turn this one off and you don't have to deal with that. What is the purpose of this one here? Of course, you can turn off the discharge MOSFETs and then you can safely connect your inverter, for example. Yeah, if you go camping, for example, and have an inverter which frequently connects and disconnects to your battery, you would need one of these pre-charge resistors to pre-charge the capacitors in your inverter to avoid a big spark and an inrush current through the BMS. But with this function, we can actually turn off the discharge MOSFETs of the BMS. So when you connect your inverter, there's no power going from the battery through the BMS into these capacitors. And once the inverter is connected, you just connect these 2 cables with your switch and it turns the discharge MOSFETs back on and charges your capacitors inside your inverter. And here in their pre-built battery from Muller, the 12.8 volt 200 ampere hour lithium iron phosphate battery, they have actually a discharge switch down here at the front panel of this battery. Turn this off, connect your load, turn this back on, no spark, no surprise, no tears. It's actually a pretty cool battery here. I linked the review and test video down below. So, and down here we can set all the protection parameters and settings for charge over temperature, charge under temperature, discharge over, discharge under, and so on, and so on, and so on. And down here we have the level 2 protection. There's an overcurrent and over voltage and under voltage, which is already preset. And the level 3 is a short current protection, 2000 amps for 400 microseconds. It recognizes there is a short and turns off the MOSFETs as well. Okay, let's go back in here and have a look at our cell voltages. So what I can see, all these cells are pretty much in line, except of cell number 1. And all the cells have voltages at around 3.25 or above, except number 1, of course. So if you go back in settings and go into our balance configuration and set the balancer to 3.2 volts, for example, and say done, and I click on BMS write, you will actually see that the light here on the PCB on the active balancer will turn on immediately. So I click on the BMS write now, and it writes the information back, and because we are over 3.2 volts now, bang, look at this. Active balancer is active now. We are balancing the whole battery with this active balancer. As well, if we go back into home, it also shows you the internal passive balancer, how it is working on these cells here. Yeah, it's trying to balance all the cells basically now, except of cell number 1. You can also see that cell number 1 has already increased in voltage here. We are down to 56 millivolt only deviation. Well, before it was clearly under 3.2 volts. So the active balancer is actually working already. Let me tell you again, this is not correct. At 3.2 volts, you should not balance your lithium iron phosphate battery. It is impossible. Yeah, all these batteries may be already balanced. We are in the absolute flat part of the charge and discharge curve of this battery now, and there's no way to distinguish the state of charge of single cells now. It is totally impossible. You can only balance your battery above 3.45 volts with lithium iron phosphate. If you have a lithium ion or LTO battery, that's fine because the voltage is linear to the state of charge. But here, lithium iron phosphate never turn on the balancer below 3.45 volts. And this is exactly what the setting was already in the BMS here, 3.45 volts start balance voltage. Perfect. So we can see again that cell number 1 is still the one with the lowest voltage, just under 3.2 volts. All the other battery cells are over 3.25 volts. And we can do an experiment and disconnect this driver cable for the active balancer. So once the balancer turns on, it doesn't activate the active balancer, but it still uses the passive balancer inside the BMS. So let me turn on the balancer again. And we can see we've got balance functionality here for all the cells again. It is trying to bring the voltage down of these cells, 150 milliamps. And we probably can see this when I use my clamp meter. Okay, this is cell number 1, cell number 2 it is. Balancing right now, 100 milliamps around. It's 100 milliamps. And now it stops again and the current goes down to almost 0. And here it comes again, 100 milliamps, 120, we can see. So I have now connected the power supply, I set it to 50, what is it? The no load voltage, 55.8 volts around. And I've limited the charge current to around 1 amp. And this is what we can see here in the app as well, charging with around 50 watts, 1 amp. I have forgotten to turn off the balancer. We should not run this. 0, done. Right back to BMS and the balancer should stop. All right, let's charge a bit faster. The capacity of these cells inside this battery here and this test battery are only 5 ampere hours. So we can fairly quickly charge and discharge this battery. Increase the charge current a bit more. The first cells are now over 3.4 volts, but this is charge voltage obviously. A bit more current, almost 4 amps now. And as soon as one of the cells hits 3.45 volts, it will start the active balancer as well as the internal passive balancer. Be cell number 9. Yep, there it is. See what happens now? Cell number 1 is the highest in the whole pack, and we have just balanced it because it was the lowest and now it is the highest. It is absolutely wrong to balance below 3.45 volts. Again, we have seen the active balancer has actually done the total opposite. It has created an imbalance. So we are now balancing cell number 1 and 9. So even this is a 5 or even 5.5 amp active balancer here. It can only balance with this high current if the voltage difference is large enough. And because all the cells are fairly close together, we've got only a delta of 50 millivolt at the moment. The balance current is obviously a lot smaller than 5 amps. But we have already tested this in the past with these active balancers. They are actually able to push 5 amps from one cell to another cell. And the other advantage is they are balancing all your cells at the same time now, while the JK active balancer balances always with 2 amps, but can handle only one cell at a time. It can only charge one cell or discharge another cell. So obviously there are pros and cons for both methods, what the JK BMS uses and here what the Muller Energy JBD BMS uses with this active capacitive balancer. Okay, let's keep the power supply on this battery here for a while until this battery is starting to get full. All right, see you in a second. Okay, my friends, I think I underestimated the capacity of our test battery here. We are charging for probably 20, 25, 30 minutes now with 55.4 volts and 4.2 amps, and the current is not going down. So obviously the state of charge was fairly low in this battery, and now we have to fully charge this 5 ampere hour 52 volts battery, and it takes longer than expected. All right, it is almost midnight now. I call it a night. We leave everything running as it is. I turn down the charge current to say we have time now, 0.8 amps. Yeah, something like this. We leave it running until tomorrow morning, and then we should see the battery fully charged, fully top balanced as well at 55.2 volts exactly. One thing I want to show you quickly here is, this test battery we have built here a while back has also a 16S active balancer. Yeah, very similar to this one, capacitive, and we actually installed a switch here to turn on and off this active balancer. Of course, I can also activate the internal active balancer. So now we have 3 balancers working on this battery. The internal passive balancer, a 16S capacitive balancer, and another 16S capacitive balancer inside this battery. So 2 active, 1 passive balancer working on this battery at the same time. You can connect as many balancers as you want, as long as you ensure that none of them turns on below 3.45 volts. But on the other hand, if you need that many balancers for balancing your battery, there's clearly something wrong with your battery, because no battery should need 3 balancers. Anyway, guys, we leave this all running as it is, and we see us again tomorrow morning. Unless this tropical cyclone is here then, and we have other stuff to do. But from what I can see, the weather forecast looks fine. Shouldn't be any major dramas. Maybe a bit of rain tomorrow, a bit of wind, and that's it. All right, see you tomorrow morning again. Have a good night's sleep. Good morning, my friends, and welcome back to the same video again. So, tropical storm or cyclone Alfred has picked up a little bit on wind speed here. We've got a little bit of drizzle. You can see that the rain is almost nothing. Some gust winds. So we are still monitoring the weather and situation. At the coast it is far more dramatic, and huge damages across the coastline already. 300,000 people without power, but here no power loss so far, nothing. It may come in the next couple of days, who knows. Well, I'm prepared. I've charged all my batteries up here. I've got around 200 kilowatt hours of energy stored from the sun. And now the rain picks up again, but we can still see I'm charging with 3 amps into the battery. So we are still making close to 1 kilowatt of solar power in these conditions, so totally fine. We are on 46%. These batteries, this one battery is close to 100 kilowatt hours already. 46%, so plenty of juice. All right, let's have a look at the battery, which has now fully charged to almost 58 volts. And we are still taking 8 milliamps into the battery. Highest cell is 3.635 and lowest number one 3.621. So fully top balanced, I would say. And probably in the last test we want to have a look at the active balancing function of this BMS. All right, so let's have a quick look at the app here. Oh, the rain picks up. Of course, start filming, the rain picks up. There was only drizzle just now when I came in. Jeez. So we can see we've got a 10 millivolt deviation here. And what's the setting? We are set this to 5 millivolt. So I wonder why the balancer is not actually activating right now and try to achieve this 5 millivolt we have set. I don't know, we are almost at 15 millivolt and the balancer is not kicking in for some reason. That is a bit strange, huh? But I have seen this before with JBD BMSs, that the set voltage delta is not really the one when the balancer kicks in. It is just a rough number, so to speak, for the BMS. But what I have here are my 12 volt light bulbs, yeah, and I want to discharge one of the cells just a tiny bit to activate the balancer. And I will just discharge cell number 1 here with the light bulb, and we want to see what the actual balance current then shows us here on the clamp meter. So I'm measuring the current going into cell number 1, which is basically nothing at the moment, and I'm touching cell number 1 just for a split second with this light bulb. Okay, there we go. Yeah, balancer kicks in, and we can immediately see that the active balancer balanced out the delta 250 milliamp, which we could see at the beginning. I'll do it again just to create a bit of delta. What do we get? 2.4 volts. Oh wow, you can see half an amp now coming from the active balancer into cell number 1. So this works really well, and this is balanced out basically in no time. So the charger has now kicked in again as well. Now it's 100 milliamps. But obviously the BMS doesn't show anything. You can see cell number 1 is still our lowest, and now the passive balancer of the BMS and active are working together to get this sorted. Yeah, and this should actually balance now down to 5 millivolt, but sometimes I've seen with JBDs they stop at 20, 15, 10 millivolt. You know, so even you set it to 10 millivolt, it always stops at 15 millivolt, for example, because this is hard-coded. Now you can see 10 millivolt, 3 cells are balancing. So now balancer has turned off and we are at 8 millivolts. See, it doesn't go all the way down to 5. It might be that 10 millivolt is the lowest threshold you can set. Even we have set 5 millivolt, which is fine. You know, 10 millivolt is totally fine. So, yeah, balancer comes back on at 15 millivolt around, and now it has turned off again, reaching 10 millivolts. So I'll just use the light bulb again, just a split second. I'll give it a bit more here. 600, 700 milliamps. You can see balance current coming from the active balancer, taking energy away from all the other cells which have a higher voltage, and put this in number 1. So that's pretty cool. I really like this functionality with the active balancer, because the internal balancer with 70 to 100 milliamps, what it says there in the specifications, this is not great. It might be good enough for such a small battery with 5 ampere hours, you know, but if you have a 280 ampere hour, I mean, forget it. So there you have it, my friends. This is the new Muller Energy 6222S lithium iron phosphate BMS from JBD, which can drive a 5 amp active balancer. And finally they designed and developed such a BMS, and it is now available on the market. So the big question, what I was thinking about when I did this testing here with this BMS, is what is it actually designed for? what is the target audience, the target customer? What is the purpose of this BMS these days, you know? I mean, we had this 4S Muller BMS, which could drive the 4S active balancer 2 years ago, right? And it was a sensation. And I said, well, is this even better than the JK BMS? Because it can balance all the cells at the same time with 5 amps, instead of only one cell with 2 amps like the JK could. But this was 2 years ago. This was before we had the JK Inverter BMS. And clearly this is a 16S 200 amp BMS, and this is a 16S 250 amp BMS. Does this make a difference? I don't think so. Who's driving 250 amps through a 16S battery? Yeah, if you do that regularly, there is clearly something wrong with your system and battery design. Unless you have a 3P 16S battery, but usually these days nobody does this anymore. We're all building separate and individual batteries these days, each with their own BMS, and then parallel them. So I don't quite see a need for a 16S or even a 22S 250 amp BMS, right? And then we have to compare it with a JK BMS, because this is clearly a competitor. And I must say, I would rather use the JK BMS than the JBD 250 amp BMS, the Muller edition. And of course, not to forget, we have the communication possibility from this BMS to an inverter. Yeah, we have individual programmable relay contacts here. We've got a charge current limiter. We've got status LED lights. Well, it's only a small feature, but this one doesn't have any lights at all. And then looking at the cabling situation, it is still a bit cleaner and better designed in the JK BMS, I think, because the Bluetooth module is already integrated. The active balancer is already integrated. We only have the balance cables, the communication cables if you want to, and that's basically it. And then, well, there is the price, right? The JBD 250 amp BMS Muller edition here is $399. But Muller Energy gives additional warranty on this BMS, which you don't get for the JK BMS. The JK comes only with 1 year standard warranty, and good luck to make a warranty claim with someone who sits in China. While Muller Energy is here in Sydney, Australia, they are shipping this 1 year worldwide, and they provide also customer service. Yeah, and I just picked a random shop here on AliExpress, and I can get the PB2A 16S 20s of the 200 amp version of the BMS, including the 4.3 inch LCD display for $322, including shipping. There's a 20% price difference between these two versions. So I think the Muller Energy JBD 250 amp BMS would have been fantastic, a fantastic BMS 2 years ago when the 4S version came out as well. But this was just before the JK Inverter BMS came out, with all these nice and wonderful features and the over-the-air software updates, which makes the JK so good. It is one of the best and most important features these days, to have software updates on your BMS. Yeah guys, let me know in the comments down below, what do you think about the Muller Energy edition of the JBD 250 amp smart BMS for lithium iron phosphate, including a 5 amp active balancer, nice designed cabling now. We've got a discharge switch here, and it can handle batteries from 6S all the way up to 22S. I have forgotten to show you. So, for example, if you have an 8S or 24 volt system, yeah, I want to use this BMS here, 250 amps make totally sense. That's around 7.5 kilowatt or something. And you only need to order a different active balancer for that, yeah? Replace the 16S with an 8S. This active balancer does all the configuration in the BMS as well. It tells basically the BMS how many cells you have connected, 16S or 8S. Yeah, my friends, as I just wanted to say, leave your comments down below. What do you think about this BMS from Muller Energy? Is it still worth buying such a BMS? What would you use it for? 16S 250 amp BMS. Wow, that's a lot of amps. That's like 13 kilowatts, right? From one battery. And as always, I link all this information about the Muller Energy BMS down under the video. You also find the link to the JK BMS, of course. And I think Muller Energy customers also get a 5% discount. I link all the information down below under the video. So should I still say JK BMS go home, here comes the new BMS king? Well, I don't know. Now that we have the JK Inverter BMS, I think the JK BMS is still the king of BMSs. And thank you so much for 105,799 subscribers. Thank you very, very much, and welcome to all the new subscribers, of course. And thank you also for all your donations, buying me a beer, a coffee, a smoothie, a tea, leaving all these nice and wonderful comments, helping other people out under the videos. Thank you so much for that. That saves me a ton of time. And all this support, of course, makes these videos possible. Otherwise, we wouldn't be able to test the Muller Energy BMS here on the channel. And guys, until the next video, when we, well, yeah. There's something not working with one of the JK BMSs, and this BMS is in the middle of the stack, so I need to got the crane already here, right? So expect some crane action in the next video. We need to get access to this BMS and see what's going on. Well, until then, guys, you stay charged. Stay safe, of course, especially with the tropical cyclone Alfred causing all this damage across the coast. Stay safe down there, and thanks again for watching. See you then. Bye-bye.